let us derive the formula for kinetic energy. Okay. This is a very, very important topic of this chapter. So first of all, we should understand that kinetic energy of a body moving with certain velocity is equal to work done on it to make it acquire that velocity. For example, if suppose if there is a football which is moving with a velocity, suppose a football is kicked and it is moving with a velocity of 2 meter per second. So because it is moving with certain speed, it has some kinetic energy, right? But to make that football move with this velocity, some force might have applied by a person. Okay, someone might have kicked it, means someone might have applied some force. It means some work is done on this football to make it move with some velocity. So whatever work is done, suppose the boy on applying a force on kicking the football does a work of say 10 joule on it. If it does a work of 10 joule on it, then while moving, whatever energy it will have, whatever kinetic energy it will have, that would also be equal to 10 joule. It means जितना वर्क डन उस पे हुआ है उतना ही काइनेटिक एनर्जी भी उस बॉडी की होगी. ठीक है. Now let us see the derivation. So first we have to consider an object having mass m which starts from rest and attains a uniform velocity v after a force F is applied on it. Okay, and during this period the object, it has been displaced by distance s. Okay, for this you will be using, let us take a figure. Let this be the ground. Okay, this will be the object which was initially at rest and now it is moving. Okay, and it has covered this much distance. This much distance, and say the distance covered is what? S. The distance covered is S, and initially the initial velocity, that is u, was 0 because initially the body was at rest. Okay, and now it has some velocity v. It is moving with some velocity v. Okay, why? Because a force is applied on it. Okay, right? So this figure we need, and the mass of the object is m. Now what we can say? Because the force F is applied and the body has covered a distance s, so the work done on the body can be written as W equals to F into S. Okay, means say this is position A and this is position B. So for these two positions from A to B, the work done on the object, that is on the box, is F into S. Correct? Okay. Now because we can see that the body is changing its velocity, it is going to have some acceleration. So let the acceleration be denoted by A. Okay, so you all know this third equation from those three equations of motion. What is the third equation? V square equals to U square. V square minus U square equals to 2as. Okay. From here, can we take the value of S? If we want to take out the value of S, it will look somewhat like this. S equals to V square minus 2as. Right? We just have to take this 2 and A on the other side in denominator. So we will get this. This is our equation 2. This was our equation 1. Also, we know that formula for force is F equals to ma from second law of motion, right? So now we have these three formulas. So what we have to do with these three formulas? We will be substituting formula second and third in equation 1. Like this value of S would be substituted over here, and this value of F would be substituted over here. So how our formula will look? Let us see that. Okay. See, here you can see that this was the second equation. This is the third equation. Substituting value of F and S in equation 1. So equation 1 was W equals to F into S. Value of F is MA. Value of S is V square minus U square upon 2A. This A and will get cancel, right? So we are left with M. So M is written over here. We are left with 2. So 2 is written over here as half. Now what about this U square? Initially the body was at rest or it was stationary. It means U is what? 0. So if U is 0, we are left only with what? V. So our work done is now equals to W equals to half mv square. W equals to half mv square. Understood? Also, we had studied just now in the beginning of this derivation, we had discussed that kinetic energy of a body is equal to the work done on it. So as the work done on the object is equal to the kinetic energy of the object, we can replace this work done, that is W, by Ek. Ek is for kinetic energy. E is for energy, K is for kinetic. Though we will write like this, but while reading we will read kinetic energy is equals to half mv square. Okay, so this is the formula that we have derived, and this is the formula which we will be using to find the kinetic energy. So to find kinetic energy, we need two things: the mass of object and velocity of object. Okay, we should have only these two things. Understood?
Excuse me, sir.
Yes.
Sir, can you explain W is equals to half mv square, how it came?
W equals to C.
Half mv square.
C. Hope this step is clear to you. We have written F equals to MA and this one. Will this A and A will get cancelled? Okay. What about this U? It is 0. So what are things left with us? See, if I'm writing, I will write a M over here. A V square is left over here, and a 2 is left in denominator. This 2, right? So this 2 is just written as half. Either we write it over here or we write it upon 2. The meaning is same. Okay. And we know that work done is equal to change in kinetic energy. So work done, that is W, can be replaced by energy. So we finally got this formula, that is kinetic energy is equals to half mv square. Okay, it is also written like this, that kinetic energy, okay, is equals to, then you can write half mv square, half mv, then square above it. Okay, square. In this way also we can write, means even we can write Ke for this. Okay, so just note this, that this diagram you need to draw by yourself. Okay, we have to show an object having initial velocity u 0, and final velocity v, distance covered s, force applied F, and the mass of the object is m. Okay, it is not there in textbook, so this you need to draw. Okay, you can take one screenshot also. Okay, so this is the derivation of kinetic energy. Now let us discuss some numericals on it. Okay, the first one is very easy one. Actually these examples are from textbook, so once you can refer the textbook also. See, it is given that an object of mass 15 kg is moving with a uniform velocity of 4 meters per second. Okay, what is the kinetic energy possessed by the object? Okay, now we know the formula. Kinetic energy is equals to what? Half mv square. It is equals to half mv square. We need only two things: mass and velocity, and we have both things. Mass is 15, velocity is 4. Okay, and one thing that you should note, that mass should be in kg, and mass should always be in kg, and velocity should always be in meter per second. If it is if the values are given in some other unit, first we should change it into the proper unit. Understood, all of you?
Yes, sir.
Okay.
Yes, sir.
So now putting the values, half into 15 into 4 into 4. Okay, and while calculation, no need to write this unit. Okay, they are written unit over here, no need to write the unit over here. Okay, just write the numbers. So this 2 and 4 will get cancelled. right? This 2 and 4 will get cancelled. And in 2 4s are, this 2 into 4 is 8, 15 8s are 120. It means the body possesses an energy of, or kinetic energy of 120 joule. Understood? So this is how we can use this
Yes,
formula
sir.
to find the kinetic energy. Okay. One more numerical is there. See, in this one, it is given that what work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour if the mass is 1500 kg. It means it is somewhat like this. I'm just drawing a box instead of a car. Okay. Okay. The car is moving. Initially, it is having a speed of what? 30 km per hour. And at this point, finally, it is having a speed of what? 60 km per hour. Okay. So it is asked that, okay, and mass of the car is 15,000 kg, 1500 kg. It is asked that how much work needs to be done. क्योंकि कुछ work करेंगे तभी तो कार की speed बढ़ेगी, right? How much work should be done? So instead of directly finding the work, what we will do? We will find the change in kinetic energy, because kinetic energy is directly equal to work done. This we had discussed. So हम पहले पता करेंगे कि kinetic energy दोनों position पे क्या है. Let this be position A. Let this be position B. Okay. So first of all, we know the formula is half mv square. But are the units proper of velocity? It is kilometer per hour. Is it
No.
proper? No. So it should be converted into what? Meter per second. So multiplying 1000 to change kilometer into meter, and multiplying by 60 into 60 to change r into second. Instead of this, you can also do this 30 into 5 upon 18. You have learned this in previous chapters, right? हम ऐसे भी कर सकते हैं. So on calculating, you will get this one, that is 25 by 3, and let it keep in fraction. Don't go in decimal point, as in fraction we will get more accurate answer. At the end we will divide if it is required. So we got u equals to 25 by 3 meter per second. Similarly, the 60 kilometer per hour can be converted by multiplying it by 5 upon 18, or that same 1000 upon 60 into 60. We will get 50 by 3 meter per second. Clear? Now, what we will do, we will find the kinetic energy at both the position, even at A, even at B. So we want to find the kinetic energy at position A, we will use this number as the velocity. That is why it is written Ki. See, Eki is written. Ek means kinetic energy, and what is I? I is for initial. I is for initial. So it is initial kinetic energy. It is initial kinetic energy. Okay. So by just putting the values, half mv square. So half, this is m 15,000, and u square, that is 25 by 3, and square of it means you will be writing it 2 times, 25 by 3 into 25 by 3. You can do the calculation later. Okay. Here you will get this answer. So this is the initial velocity, initial kinetic energy which the body was having at position A. Now when the body will reach position B, so we will find the final kinetic energy. So we have written EKF. F means for final. So in this case, we will be using the velocity, that is final velocity, that is 50 by 3. This one, V. Okay, so here we will get this. So we can see that here we can clearly see that it was this 156250, and here it is 625000 upon 3. So there is a change in kinetic energy. So let us find the change in kinetic energy. How we can find that? We simply have to subtract them. So you have to just subtract them. Means 625000 upon 3 minus 15625 upon 3. So on subtracting, you will get this. Okay. It means यहाँ से इतने दूर में, यानी इस वेलोसिटी को चेंज करने में जो काइनेटिक एनर्जी में चेंज हुआ है वो कितना है? 156250 जूल. And as we know that काइनेटिक एनर्जी चेंज होता है तो वो इट डिपेंड्स ऑन द वर्क डन. जितना वर्क डन होगा उतना ही काइनेटिक एनर्जी चेंज होगा. सो वर्क डन इज इक्वल्स टू change in kinetic energy. So what we can say, This is also equal to the work done to change the speed of body from 30 km per hour to 60 km per hour. Understood? See, now
Yes,
here
sir.
we are not doing the calculations. So as we can finish this in minimum time, but after completing these classes, you have to do these numericals, each and every step. Okay, all the calculations you need to do today itself. Okay, hope it is clear to everyone.
Yes, sir. Yes,
Okay,
sir.
our next topic is potential energy. Yeah. So what do we mean by potential energy? So potential energy of an object is the energy possessed by the object due to its position or shape. Okay, means if the position of an object is changed or a shape of an object is changed, it acquires some energy in it, and that energy is known as potential energy. For example, water stored in a dam has a large amount of potential energy due to its height above the ground. For example, we know that to make a dam, a very long wall is constructed, and behind which a lot of water is collected, right? So water is collected at a certain height, and because of this height at which the water is collected, it has energy in it. Okay, and that energy is known as potential energy. Also, a stretched rubber band possesses potential energy due to its distorted shape. जैसे कोई rubber band है, उसको तुमने stretch करके इतना बड़ा कर दिया, so it will have some energy in it. Okay, because the shape is distorted or the shape is changed. Also, a stretched or compressed coiled spring. For example, suppose there is a coil, okay, and by applying force on it, you have compressed it. तुमने उसे क्या कर दिया? कंप्रेस कर दिया. तो स्प्रिंग में क्या हो जाएगा? एक एनर्जी प्रोसेस हो जाएगी. जैसे हम उसको छोड़ेंगे, वो वापस से कुछ वर्क डन कर सकता है, राइट? So these are the examples of the objects having potential energy. Further, this potential energy is divided into two types, or it is classified into two types. That is gravitational potential energy and elastic potential energy. Okay. So what is gravitational potential energy? It is the energy possessed by a body due to its position above the ground. For example, अगर किसी brick को हम ground से, see, initially if the brick is at ground, it doesn't have any energy. But अगर हम उसे ऊपर लेकर जा रहे हैं और हमने किसी रूफ टॉप पर रख दिया, तो उसे ऊपर ले जाने में हमने कुछ तो वर्क डन किया ना उसके ऊपर. तो जो भी वर्क डन हम उस ब्रिक के ऊपर करेंगे ऊपर ले जाने में, वही वर्क डन उसमें स्टोर होता है इन फॉर्म ऑफ पोटेंशियल एनर्जी. ओके, फॉर एग्जांपल, इफ सपोज यू डिड 10 जूल ऑफ वर्क on taking this brick from ground to rooftop, so in that brick now the potential energy would be equals to what? 10 joule, like that. Okay, so अगर किसी बॉडी में किसी हाइट पे होने की वजह से उसमें पोटेंशियल एनर्जी है, so that potential energy is known as gravitational potential energy. Why? Because the body is taken against the gravitational force. ये gravitational force के against ऊपर जा रहा है, right? Similarly, what do you mean by elastic potential energy? It is the energy possessed by a body due to its change in shape. For example, if suppose there is a, in case of arrow and bow, okay, when the this string of or a thread or this, okay, when this string of the bow is stretched, okay, it has some potential energy. Why? Because it possesses potential energy. Why? Because there is a change in shape. There's a change in shape, and when we will release it, that because of that potential energy, this arrow starts moving forward. Okay, क्योंकि वो energy अब किसको transfer हो गई है? Arrow को. So here the bow is using a elastic potential energy. Understood? And same is the case for spring. अगर तुमने किसी spring को press किया, वो हो गया compressed, तो कंप्रेस होने के बाद स्प्रिंग भी वापस रिटर्न फोर्स लगाता है हमारे ऊपर, ऊपर आने की कोशिश करता है. ओके, व्हाई? बिकॉज ऑफ इलास्टिक पोटेंशियल एनर्जी स्टोर्ड इन इट. अंडरस्टूड? तो जो भी हम वर्क डन कर रहे हैं शेप चेंज करने के लिए बॉडी का, that much amount of work is stored in that body in form of elastic potential energy. Hope it is clear to everyone.
Yes, sir.
Yes, sir.
Now in this chapter we would be discussing this energy in bit detail. Okay, so let us see that what do we mean by gravitational potential energy. Okay, and what is the formula to find that. Okay, so here we can see that see when an object is raised to a height, किसी भी ऑब्जेक्ट को अगर किसी हाइट पे ले जाएंगे, so its energy increases because work is done on it against the gravity. For example, you can look at this figure. The block is kept on the ground, it is taken to height h, so some work is done. उस पर force तो लगाएंगे ही हम, and because of that force and even the distance is covered, so some work is done on it. Okay, and that work is stored in form of potential energy. Okay, the energy present in such an object is known as gravitational potential energy because it is going against the gravity. Now to derive the formula, we have to consider an object of mass m. So let this be the object of mass m raised to height h from the ground. So it has been raised to height h, and for which a force required to raise the object is equal to the weight of the object. Means अगर तुम्हें कोई object raise करना है तो तुम्हें एटलीस्ट कितना फोर्स लगाना पड़ेगा, जितना उसका वेट है, उससे कम में तो ऑब्जेक्ट उठने वाला नहीं. करेक्ट? सो दैट इज व्हाई इफ so what we can say that the force that we are applying on it, it is mg. Even in the previous numerical we had discussed this, we had used this. Okay, so work done equals to force into displacement. This formula we know. Now force can be written as mg. G is the gravity and displacement is h over here. Okay, displacement is h over here because it's a height. So finally it becomes mgh. So w equals to mgh. Now as we discussed, whatever work done is done on the body, the same amount of energy is stored in the body. It means what? The work done, see it is written, since the work done on the object is equal to mgh, the energy would also be equal to mgh, and that is why the potential energy, that is ep, E is for energy, p is for potential. You can also write p dot e, potential energy, that would be equals to mgh. So this is the second formula that we have learned. This is the second formula that we have learned, that is E equals to mgh. It is a formula of potential energy, and for kinetic it was half mv square. Okay, so this is the derivation of the formula of potential energy. Hope it's clear to everyone. Is it clear?
Yes, sir.
Yes, sir.
Okay, okay. So now let us move to the next topic. That is, okay, it is the same thing. How to derive gravitational potential energy? Okay, yeah, one more thing. See, if suppose a body is raised directly at this height in a straight line, or the body is taken through this path, यानी पहले हम ऑब्जेक्ट को यहाँ ले गए, फिर यहाँ से हम यहाँ ले गए, फिर यहाँ से हम from here we brought it to this position. So will there be any change in the amount of potential energy because the path is different in the second case? So answer is no. Answer is no. Why? Because the work done by gravity depends only on the difference between vertical heights of initial and final position. यानी उसे सिर्फ इस डिफरेंस से मतलब है, ओनली द डिफरेंस मैटर किया, इस दो पोजीशन के बीच में डिफरेंस कितना है, whether it is 20 meter or 10 meter, it doesn't depends on the path through which the body has brought to that height. Okay, हम स्ट्रेट ले जाए तो भी उतना ही होगा, हम किसी और पाथ से लेके जाए तो भी उतना ही होगा, पोटेंशियल एनर्जी उतनी ही होगी. So if a block is raised from position A to B by taking two different paths, and if the height is h, okay, in both the case the height is going to be h. So for both the cases the work done on the body would be equals to WmgH. W equals to mgh. So even the potential energy for both the body should be, or in both the case, would be equal to mgh. Understood? So what you understood from this, that potential energy doesn't depends on the path. It only depends on the initial position and the final position and the distance or the gap between these two positions, or the difference between those two positions. That's it. Understood, all of you?
Yes, sir.
Okay.
Yes, sir.
The next one. Okay, here's a numerical. All of you once go through this numerical. I'm giving you a minute. Yeah. So what is given over here? It is asked to find the energy possessed by an object of mass 10 kg when it is at the height 6 meter above the ground, where the value of g should be 9.8 meter per second square. Okay. So we have to find the energy possessed by an object. So here it is not mentioned that you have to find the kinetic energy or you have to find the potential energy. But we should know that if a body is at some height, of course, it will have what? It will have potential energy, right? So we will be finding potential energy. So first, let us see the formula. What is the formula for finding potential energy? You know, the formula is equals to what? P of E is equals to
MGH.
mgh. So let us see. Do we have all these quantity, all these values? Do we have the value of m? Yes,
Yes.
it is
Yes, 10
10
kg.
kg. Do we have the value of g?
Yes.
Yes,
6 meter.
9.8. Array, it is 9.8 meter per second square. Do we have the value of h? Yes, it is 6 meter. So we just
Yes.
have to keep the values in formula. That is potential energy equals to mgh. Keep the values and just simply multiply it. You will get the answer. Okay, you can do it later also. Understood? So it is very, very simple. So is this clear? This example is clear to everyone?
Yes,
Yes,
sir.
sir. Yes, sir.
Now a bit difficult one. Yeah. See the second numerical. An object of mass 12 kg is at a certain height above a ground. If the potential energy of the object is 480 joule, find the height at which the object is with respect to the ground. It means what? Suppose it's a ground. Okay. Object is at certain height from the ground. Let this height be h. Okay. It is at this height. The mass is given. It is 12 kg. Okay. And what is the energy it has at this point? It is 480 joule. And the mass is 12 kg. So we have to find h. So what we will do? We will use this formula. That is potential energy is equals to mgh. We will use this formula. And because we want to find height, or what we can do, we can simply put the formulas also. Like we can put the values also. So putting the values, value of energy is 480 joule. This we have. Mass is 12. This we have. Value of g here instead of 9.8, 10 is given. So we will use 10 over here, right? Now, as we have to find h, what we can do? We can take this 12 in denominator. Also, we can take this 10 in denominator. So it will look somewhat like this. That 480 upon 12 into 10. So that is 120. So 480 upon 180, 0 will get cancelled. And 12 for the 48. 12 for the 48. So it means the height is 4 meter. Okay. In all such problems, you should be very careful about the units. Whether the unit is in kg or not, whether the velocity is or the expression is in proper unit or not. Okay. Only after verifying the unit, you have to put the values. Is it clear to everyone?
Yes, sir.
Okay. Understood all of you
Yes, sir.
how we solve this numerical?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Now the next topic of this chapter. The next topic is transformation of energy. Okay. Now what do you mean by transformation of energy? So it simply means the conversion of energy from one form to another form is called transformation of energy. Okay. And whenever this transformation occurs or whenever this conversion of energy occurs, the energy is means when energy is converted from one form to another form, the total energy always remains same. Okay, I will explain you what does it mean. I'm giving a simple example of energy of conversion of energy. Okay, for example, in this figure, uh, suppose this string is stretched. Okay, the string of the bow is stretched in this figure. The string is stretched. So string has which kind of energy in it? It has elastic potential energy. Okay.
Potential energy.
Okay.
Potential energy.
Okay. Now when the arrow would be released, string will again come back to its position and arrow will start moving. So now arrow has which kind of energy if it is moving? If an arrow is moving, it will have which kind of energy? Kinetic energy. And this string was having potential energy, right?
Potential.
So what we can see over here, that the potential energy of string has been converted into what? Kinetic energy of the string. Okay, so this is a type of conversion. Okay, now suppose the potential energy of the elastic of this string was 5 joule. If it was 5 joule, तो जितना potential energy 5 joule रहा होगा. So after when the this is in motion, this arrow, so arrow will be moving with a kinetic energy of what? 5 joule. Understood? ये भी कितने से move होगा? 5 joule से ही होगा. It means the total energy will remain constant. Either it is in form of kinetic energy or it is in form of potential energy or any other form, but the total energy will remain constant. Understood? This is the meaning
Yes,
of
sir.
that statement. Okay. We will see 2 more examples, but before that, first let us read this one. That is the law of conservation of energy. This you need to learn this definition, this statement, this law. Okay. Okay. The law of conservation of energy states that, it starts from here, states that energy can only be converted from one form to another. Okay. It can neither be created nor be destroyed. The total energy before and after the transformation remains same. It remains same. It means what? In the whole universe, or we can say on the whole earth, the total amount of energy is constant. The total amount of energy is constant, and it only changes in from one form to another form. I'm giving you an example. Suppose if I'm taking an example of electricity. Okay. Suppose there is a dam. Okay. There is a dam. From dam, the water flows. The water flows from dam. So the stored water in dam has potential energy, right? It has potential energy. The flowing water has what? Kinetic energy. It will have what? Kinetic energy. Okay. By using some turbines or wheels, that energy is converted into what? Electrical energy. It is converted into electrical energy. Okay. Then that electrical energy reaches our home. It reaches our home. And in home, if suppose you are playing, suppose we are using up this energy to blow a bulb, then that energy is converted into what? Light energy. And even it produces heat. So also it produces heat energy. So here what we can say, that the potential energy of dam or of water was converted into kinetic energy. Then it was converted into electrical energy, which is converted into light and heat energy. So here only the transformation of energy takes place. कुछ नया से कोई एनर्जी क्रिएट नहीं होगा और नए से कोई एनर्जी डिस्ट्रॉय नहीं हो सकती. It can only be converted from one form to another form. Understood? Okay. Also we can see this. Suppose the electrical energy is 10 joule. Suppose it is 10 joule. Okay. So on converting into light and heat, it may be possible that 8 joule of energy is converted into light and 2 joule of energy is converted into heat. So again, even after conversion, the total amount remains same. That is 8 plus 2 will remain 10. Understood? So this is the meaning of this law, that total energy remains constant and no energy can be created nor be destroyed. It only converts from one form to another form. Okay.